For nearly a century, the public perception of dinosaurs was one of evolutionary failures, depicted as lumbering, swamp-dwelling lizards destined for extinction due to their supposed lack of speed and cognitive ability. These archaic reconstructions dominated the halls of natural history museums, presenting massive creatures dragging heavy tails across primeval mud, their small brains incapable of complex social behaviors or rapid tactical movement. This scientific consensus painted a picture of cold-blooded beasts that were slaves to the sun, requiring hours of basking just to move their massive frames through the dense prehistoric foliage. They were seen as biological dead ends, sluggish and dim-witted animals that only survived as long as they did because the world was supposedly as slow and static as they were. But in the summer of 1964, on the arid slopes of the Cloverleaf Formation in Montana, a discovery was made that would shatter these long-held misconceptions and rewrite the history of life. Paleontologist John Ostrom and his team unearthed the remains of a creature unlike any they had seen before, a small, bipedal predator that defied the established rules of dinosaurian biology. Ostrom named this animal Deinonychus antirrhopus, meaning terrible claw, a name that hinted at the specialized anatomical features that would soon revolutionize the entire field of paleontology and evolutionary science. The skeleton of Deinonychus revealed a creature built for extreme agility, boasting a lightweight frame and a rigid horizontal posture that suggested a much more active lifestyle than previously thought possible. Unlike the tail draggers of the Victorian era, Deinonychus possessed specialized bundles of bony rods along its tail vertebrae, which allowed the tail to act as a stiffened counterbalance during high-speed maneuvers. This biological engineering meant that the animal could turn on a dime, maintaining its balance while chasing down prey with the precision and grace of a modern mammalian predator. But the most shocking feature was the second toe of each foot, which bore a massive, sickle-shaped claw designed not for walking, but for delivering a lethal slashing blow to its victims. Ostrom realized that for such a specialized weapon to be effective, Deinonychus had to be capable of sophisticated athletic movements that were entirely inconsistent with a slow, cold-blooded metabolism. The sheer physical demands of jumping, balancing on one leg, and kicking with such force required a cardiovascular system and a metabolic rate far more advanced than that of any reptile. This sparked the dinosaur renaissance, a period of intense scientific debate that challenged the idea of dinosaurs as ectotherms and proposed that they were, in fact, warm-blooded, active animals. The implications were profound. If dinosaurs were warm-blooded, they would have needed to eat more frequently, move more constantly, and perhaps even possess complex social structures for hunting and protection. John Ostrom's work also revitalized a forgotten connection, first proposed by Thomas Huxley in the 19th century, the strikingly close evolutionary relationship between small predatory dinosaurs and modern birds. Deinonychus shared numerous skeletal features with birds, including the structure of the wrists, the wishbone, and the hollow, air-filled bones that reduced weight without sacrificing structural integrity. This link suggested that the very traits we associate with avian success, high metabolism, intelligence, and agility, did not originate with birds, but were already present in their dinosaurian ancestors. The discovery of Deinonychus effectively killed the stupid dinosaur myth by demonstrating that these creatures were highly efficient biological machines optimized for survival in a competitive world. As the evidence mounted, the scientific community began to see the Cretaceous period not as a slow-motion gallery of monsters, but as a vibrant, high-energy ecosystem of sophisticated predators and prey. The traditional view of the sluggish lizard was replaced by the image of a feathered, sharp-eyed hunter, capable of planning attacks and navigating its environment with startling precision. This shift in perspective was not merely academic, it permeated popular culture, eventually inspiring the terrifyingly intelligent velociraptors that would captivate the world in the blockbuster film Jurassic Park. While the movie took creative liberties with size and taxonomy, the core concept that these animals were fast, smart, and lethal was a direct result of the research started by John Ostrom. Modern paleontology now uses advanced CT scanning and biomechanical modeling to confirm what Ostrom first suspected. Dinosaurs had brain-to-body ratios that suggested complex behavioral capacities. Specifically, the dromaeosaurid family, to which Deinonychus belongs, possessed enlarged regions of the brain dedicated to sensory processing, coordination, and perhaps even basic tactical problem-solving. The myth of the stupid dinosaur was a product of our own limited imagination and the fragmentary nature of the fossil record available during the early days of the science. With the discovery of Deinonychus, the veil was lifted, revealing a lineage of animals that dominated the Earth for over 160 million years, a feat impossible for a slow or failing group. To survive and thrive across multiple mass extinctions and shifting continents, dinosaurs had to be remarkably adaptable, possessing a biological plasticity that we are only now beginning to fully appreciate. The discovery of feathers on many small theropods, including relatives of Deinonychus, provided the final visual proof of their warm-blooded nature and their intimate connection to the avian world. These feathers were likely used for insulation, display, and eventually the evolution of flight, further distancing these animals from the scaly, cold lizards of our past imagination. Every time we look at a modern bird of prey, from the sharp gaze of an eagle to the silent strike of an owl, we are witnessing the living legacy of the Deinonychus. The terrible claw was not just a weapon of death. It was a key that unlocked a new understanding of life's potential for speed, intelligence, and endurance. It forced scientists to ask better questions. How did they breathe? How did they grow so fast? How did they manage to conquer every corner of the planet? The answers continue to reveal a group of animals that were the pinnacle of evolution in their time, mastering the land with an efficiency that has rarely been matched since. Today, the name Deinonychus is synonymous with the scientific revolution that rescued dinosaurs from the dustbin of history and restored them to their rightful place as kings of the Mesozoic. The legacy of John Ostrom's find reminds us that science is a living process, where a single bone can overturn decades of dogma if we are willing to follow the evidence. We no longer see dinosaurs as a tragedy of extinction, but as a triumph of biological engineering and a testament to the resilience of the vertebrate lineage. They were not the slow, stupid failures of our early theories. They were the fast, intelligent, and vibrant masters of a world that existed for eons before we arrived. The sickle-clawed predator of Montana proved that speed and smarts were not a modern invention, but an ancient legacy etched into the very bones of the Earth. In the end, the story of Deinonychus is more than just a paleontological discovery. It is a story about the power of perspective and the ever-evolving nature of human knowledge. It taught us that the past is never truly dead, but is constantly being rediscovered, redefined, and reborn through the tireless curiosity of the human spirit. So, when you look at the skeleton of a dinosaur, do not see a relic of a slow-moving past, but a blueprint of an active and sophisticated history. The dinosaur renaissance started with one terrible claw, and it ended by changing the way we see the entire natural world and our own place within it. Because they were never the monsters we imagined, they were the magnificent reality that paved the way for the world we know today.